In order to plot some data and analyze in Excel, I just want to quickly review what we have to do in order to do that. You should hopefully remember that these are cells and you can essentially put whatever information you would like in. So if I want to take a look at the effect of frequency and wavelength, I'm just very simply going to type those in. Now the problem here is, let's say I want to put like 1.7 hertz. You'll notice that the number, what I've put in this box, stays on the left side. If it's on the left side, that just means that Excel doesn't recognize it as a number. It just recognizes it as like text or whatever you put in. So the problem is, if I want Excel to do math, I can't have the units here. So what I'll have to do is I'll go up top and I'll put my units here. And you'll notice if I eliminate them from this, as soon as I hit enter, that 1.7 jumps to the right side. That's just a quick way of realizing or being told that Excel recognizes this as a number. It will do calculations using that number. So just make sure your units are not in these columns. They should be up in the header. So wavelength is also the distance, so I will measure that in meters. Right now I already have some values that I took from the simulation, so I'm just going to use these. I just copied and pasted those in. So you would enter these yourself. Now, if you want to graph anything, you just very simply highlight the numbers you'd like to include. Choose what type of graph. We typically do a scatter plot. Okay, so I wanted with something that looks like this. Okay, so I don't like this legend, so I get rid of the legend usually. If I want to change this layout, let me slide this over so we can still see. Okay, if I go up here to chart layout, I can add whatever I would want. So if I want to add a title, I can put it above. Overlap just means it'll be over in this section, over the data. I don't really like that, so I'll put it above the chart. All right, we need some kind of title, so I will say, I don't know, the effect of frequency on wavelength. Well, the effect of frequency on wavelength. All right, so now we have a title. Let's add some axes title. So horizontal, let's put it below. Of course, it's not going to show up on the screen. So this goes from 0 to 3.5. You can see from over here that probably signifies that would be frequency, because wavelength, much smaller numbers. Very small numbers here, very small numbers on the y. That would tell me that my y-axis is wavelength. So down here, this will be frequency. And of course, that's measured in hertz. We should always include our units. Let's put a vertical axis. Let's rotate it. All right, and this is going to be wavelength. And that's in meters. So now I have a nice graph. I know what's being measured on each axis. I have some random points here. Now we want to understand, is there a trend? Is there a relationship? So the way to do this, I find the best, is to hold down Control, click on one of your data points, any of them, and go to Add Trend Line. Now we have a few options here. Right? Right now the default for type is linear. Now linear, I wouldn't agree. This kind of seems like it should have a slight curve to it. So linear is not the best fit here because these points are really far away. These ones are okay, but you can see it's not really a straight line. If I choose logarithmic, well that does curve to it. That looks a little bit, it's definitely better than linear. You should be able to see that. It definitely represents your data better. This one's still a little bit far out. The rest is 50-50. Polynomial. Well, right now, one of these two, it looks like polynomial is a little bit better. But we want to check all of them. So this one's still a little bit far out. This one's a little bit off. So we check power. You should notice right now that compared to the other ones, especially linear, that's linear versus power. Logarithmic versus power. Polynomial versus power. Power does seem to be the best fit here. You can check exponential. That's definitely not the best. Moving average is usually a weird one. I'm going to stick with power in this case. Power tends to fit this data the best. Before I hit OK, I'm going to go into options. And generally, I want to display my equation on the chart. I get it over here, and I will hit OK. This is how you generally tend to find the best relationship. So it's hard to say what this actual relationship is, other than saying right now that there seems to be a power relationship. But this is how I would get the equation of my line. So this is how you plot points, put in a trend line, and you display the equation. Again, if you ever wanted to go back in, Control click is the big thing here. Control click on your trend line. You can format the trend line. I could go back in, change the type, change the options. I could change the color of the line, things like that, all that. If I wanted to change something with my data, I would choose one of the points, Control click, and then I could format the series. So Control clicking is your best bet here if you want to change something. But this would be essentially what you want to produce as an end result. I have a nice title. I know exactly what I'm measuring. I know the exact units that they're being measured in. I have some kind of relationship graphically so I can see what's happening. It looks to me like as I increase the frequency, so as frequency is being increased as I move over on the right, wavelength certainly seems to be decreasing. Okay, so as I move to the right, this line appears to travel down in the y direction, but it's not a straight line, so I can't say it's linear. That's where this equation would come in, and then I'd have to further analyze this. So that would be how you plot these points. Hopefully this helps.